Okay, today we're going to go over the chessboard side programming. This is for actually for op 2. We've already have programs for op 1, preparing these, the bottoms, getting them ready to go. So today we're just going to go over this op 2 programming. If you look in your levels, the first thing you want to do is you want to turn everything off so we only see the one side that we're programming. So I believe side 1 needs to be active, and I'm going to turn off the board and then side 2. Okay, now I'm also going to get rid of this other side so it's not hanging around. So I'm just going to right click and I'm going to throw it on a different level, and we'll just throw it on level 10 and then turn 10 off. So you should see your one side here. Now, the first thing I always like to do before I go any further is I like to set my plane. So we're going to create a new plane, dynamic, and we're going to put it off this back center of this stock. And now if you don't have this white stock box on here, all I did was create a bounding box to create that. So go ahead and create your bounding box, but you should have it on there. If you should have used it for the design to make sure that all of your 3D images fit within the stock. So we're going to call this mill. And then I'm going to make that plane active with my work coordinate system, my construction plane and tool plane. Okay, so that's ready to go. Now I want to actually create my containment boundaries before I start programming. So I'm going to go into levels and I'm going to create a new level, and we'll just call it boundary. Okay, now to create these boundaries, what I'm going to do is I'm going to grab the surfaces I want to create them from. So the 3 top surface and the bottom surface. And I'm going to push the Alt-E key, and that's going to hide only those surfaces. Now that makes it really easy for me to grab those and do a curve all edges. Now I green check, and now it created the lines that I need. It's got a few extra lines in here I don't need though, so I'm going to turn off my sides 1, and I'm just going to delete these holes and these 2 extra lines. And we have 2 more still. And all I was doing is selecting those and pushing the delete key in the keyboard. But now you can see I have these 2 containment boundaries, one on the top, one on the bottom. Those are what we're going to use to keep our tool where it needs to be while we're programming today. So we'll turn side 1 back on. We have our containment boundaries created, our plane set. So now we're ready to go to machine, mill, default. And then if I go to my tool paths, you should see we're going to delete this toolpath group 1. If you should only see 1 on here. Yours will probably be called machine group 1. So now we're going to go up and we're going to set up our tool settings. I'm going to assign numbers sequentially and warn of duplicates. And then under stock setup, I'm just going to push all entities, and then it should just create a nice boundary around here. So it set up everything, make sure it's displayed, green check. Okay, so you can see the red there, and now we can see where that stock's going to be. Now, we could create a solid and make that our stock model that was more representative of what we actually have, but this will be fine for what we're doing. If you want to get rid of these white lines that were your bounding box, you can also get rid of those. We have no more need for them if they get in your way for clicking. So you can select them all and just delete them. And then you can also turn off your stock model that we just created by clicking the display button. So now we're ready to start programming My first tool path, I'm just going to create an area rough with a 1/2 inch end mill, and I'm going to use that to do my initial rough pass. So tool pass, you got to select OptiRough, and then go up to toolpath type and change it to area rough. And then under the model geometry, we're going to select everything here. And we're going to leave 20 thousandths stock allowance. Under toolpath control, now we're actually going to select this bottom boundary. So not the top one, make sure you select the bottom one. And then we're going to jump to the outside, but we're going to tell it an offset distance of -0.2. So what that's going to do is make it so that the cutter does jump to the outside, but not so far as that the 1/2 inch end mill will drop down the sides of the part. So now under tool, we'll select our 1/2 inch end mill. So filter, push our none button and our flat. 1/2 inch flat end mill. I'm going to run this at 5,000 RPM. And then we'll go 5% of my cutter size chip load. It puts me at 100 inches a minute. We're not going to worry about stock or holder. Under cut parameters, we're just going to take a 30,000 step down. Leave the percentage step over alone. That'll be fine. Under my steep shallow, we're going to do detect limits, and then under the maximum depth, we're going to change it to -570 thousandths. That's going to put us so that no matter what happens, my cutter never drops down below the bottom portion, which is what is clamped in place. And then I don't want to retract 2 inches. I'm only going to retract 1 inch. And then I'm going to turn my coolant on. And that should be everything I need for this tool path. And since I'm using an STL file on these, they take a long time to calculate. So just let them work. Let it do its job. Sometimes you'll see some numbers down here calculating that looks like it's taking a long time. It is. I'll go ahead and pause and fast forward through the long calculations in this video to make it quicker, but there may be times when you're waiting, minutes, if not 5 minutes for something to calculate, and that's fine. That's a normal process. So I'm going to go into levels and turn my sides back on. So this one went pretty quick. Looks like a pretty good roughing program to get that initial stock off of there. Jumping around a lot, I probably could have changed my cut direction to zigzag, so feel free to do that if you want. I'm going to go ahead and just leave it this like that for now. Now, since I have that 1/2 inch end mill out, I'm going to finish this back ledge, and I'm going to cut it in 2 passes, but I'm going to stop and create 2 different programs. So we want to run the first program, leaving 10 thousandths, and then we'll actually go ahead into the machine and we'll mic this ledge and make sure that it's the 1/2 inch dimension that we want. We can adjust our Z at the machine at that point and then run the finish pass. And only doing that because we've got 4 of these that are all going to connect together with a board. And when it all bolts together to get these seamless joints, we have to make sure this depth is perfect at the machine. So we program it in a way that allows us to stop and do an adjustment mid-program. So I'm going to run a contour. I'm My chain is going to be just this one line. I'm going to use that same 1/2 inch end mill. We're only going to run it at 20 inches a minute because this is basically a finished pass along there. Under cut parameters, we're going to leave our 10 thousandths dimension. And then linking parameter, everything else should be good just to stay how it is. We'll turn our coolant on. And you can see it just takes that one pass on there. So that's our rough pass. Now we're going to copy and paste this, take our finished pass. So and the only thing we're going to change is the cut parameters, the stock allowance. We're going to put it at 0. So we'll calculate that. So there is my rough and finished pass for that back ledge. Now I'm going to go ahead and I'm going to create a raster tool path with a 1/2 inch ball. And this is going to kind of be like a semi-finished tool path that's going to cut this closer to net shape. It'll squawk and squeal a little bit while it's running as it goes up and down over these parts, but we're going to be still leaving the stock allowance, so it shouldn't leave any chatter, any significant chatter that won't clean up in the finish. So to create this tool path, we're going to go to tool paths and then a raster. Okay, so for our machining, we're going to select everything again. And with this one, we're going to leave 10,000 stock. Under our toolpath control, now we're going to select the top chain. So I'll go to my levels and turn my side 1 off again. And select my top chain. And then we'll do the same thing. We'll compensate to the outside at a -0.2. That'll let it kind of roll over the edges, but not actually drop down the edge. For my tool, we're going to go to the library, turn on the ball cutters, and grab a 1/2 inch ball. Should come in as tool 2. We'll run this at the same 5,100. For our step over, we're going to go 30 thousandths. And then linking parameters, we don't want to retract over 1 inch. Under your cut parameters, make sure it is zigzag. And then we're going to turn our coolant on. And we're going to let it calculate. Okay, so that's done calculating. So you can see that was a pretty simple tool path, 1/2 inch ball. It just kind of takes this closer to net shape. Now, I want to go in and I want to run a re-rough program before I run my finish cutter. I always like to rough it down 1 cutter size smaller than what I'm going to finish. I plan on using a 1/4 inch ball to finish this part. So I'm going to use a 3/16 flat to re-rough it. And what it's going to do is it's going to dig out around these areas so that when my 1/4 inch ball goes in and out, it doesn't create shatter marks. So to do so, I find that Mastercam works the best if you're actually programming the re-roughs off of a stock model. So I'm going to create a stock model based on what we've done so far. So I'm going to come up here to stock model, and it just defaults to 1. I'm going to press all entities as my stock configuration, and you'll see it'll fill in these numbers here in a second. Okay, so it's just creating that same box that we had earlier. Now under source operations, I'm going to select, click the top one, hold the shift key, and then down to the 4, all of those operations, and green check. And now it's actually going to calculate the stock model as if it was a toolpath. So now this gives me, other than this outside part, this gives me a pretty accurate representation of what my part's looking like right now. And that's going to help that re-rough cutter to know where it has to go and where it can stay out of. So now to create that re-rough, it is this same area rough up here. So I'm going to copy it, and I'm going to paste it, and that's going to bring a lot of the parameters down with it. And then under parameters, under the model geometry, we're going to leave that at 20 thousandths. Toolpath control is working off of that bottom one. I'm going to actually change that up to the top one now. So I'm going to go into my bounding chain, right click, rechain all, and we can shut our level off. So I can just grab that top one. Green check that. Green check. Now, for my tool, whoops, hold on. Under the toolpath control, it's at that outside of -0.2. We're just going to switch it back to center for this one, because we don't want it rolling over any of these edges at all. For my tool, I'm going to grab a 3/16 flat end mill. So select tool from library. Filter, we'll go back to flat end mill. 3/16 is one size smaller than a quarter, and a quarter is what we want to finish with. Now we'll go 1% of chip load, so 0.0018 gets me down to 36 inches a minute, which is fine. So under stock, I want to do a rust material cut, so that I'm going to use one other operation, and I'm going to use this stock model. So that's how it's going to tell. Don't cut everything. Just cut what you need to based on what this stock model left. So we're only going to take a 10,000th step down in my cut parameters. And then we're going to leave everything else alone. I do want to put this, yeah, we'll leave it at climb. Coolant's on, so everything looks good there. So we'll turn our part back on. And then this one, because I copied it down, it is dirty, so it has to be regenerated this way. Okay, so now that's done. We take a look at it, and you can see it just remachined around the little baby Yoda, the Mando, and then the Razor Crest over here. Just what we wanted to remachine. Get all that extra little stock out of there so that 1/4-inch ball isn't hitting it. Now we're going to go ahead and create our finish program with our 1/4-inch ball. It's going to be the same raster program that we used up above. So toolpath number 4, we're going to copy and paste. We're going to go into our parameters. So first thing under model geometry, we're changing it to 0 thou stock allowance, because this is going to be our finish program. Our toolpath control will stay the same, except for our outside of -0.2, we're going to make -0.05, because it's a smaller cutter, so we have to change how far outside of our containment boundary it's allowed to go. Under our tool, we're going to grab a 1/4-inch ball cutter. So there's my 1/4 ball. Oops, what? I didn't grab it. 1/4 ball. 5,000 RPM. We're just going to finish at 45 inches a minute with a 1/4-inch ball cutter. Under our cut parameters, we want to make sure it's on zigzag, and then we're only going to take 5,000 step over, and this is going to make it look real nice. So we don't have to worry about steep shallows because of our containment boundaries. 1-inch retract and linking parameters, and then our coolant is on. That should do for that cutter. So we have to calculate dirty. Okay, so that one's done. And we can take a look at it. Yep, should be a nice tool path, covering over everything. Doesn't drop down off my part anywhere. That looks really good. Now we're going to create a pencil tool path that's basically going to remachine in here to get everything picked out down to an 1/8 inch ball. So we'll go to tool paths and our pencil. Select everything. Under our toolpath control, we want to select our top chain again. So we'll green check that. Under our tool, we're going to grab an 1/8 inch ball. RPM. We're only going to run this at 20 inches a minute. Under our stock, we're going to use the previous operation. So toolpath 7. And then under our cut parameters, we're going to change it to a 3,000 step over. Now also where it says maximum number of offsets at 0, you want to uncheck that. And what that's going to do is it's going to allow it to figure out exactly how many step overs it needs to do based on what we had in the stock model. So from there, we only want a 1-inch retract. And then this is one of the tool paths where I actually decrease some of the sizes of all of these entries and exits, because we don't need 75 thousandths of entry and exit move when we're only using a little 1/8 inch ball cutter to run a remachine. And then we'll turn our coolant on and we'll green check that. And these pencils, they take a lot longer to calculate. All right, now that's done, we can zoom in here and see that it did a pretty good job of remachining all those areas down to an 1/8 inch ball. Now, if you want a little more detail, you can take it down to a 1/16 ball. And at this point, that's pretty easy to do. If you just copy this tool path and paste it. Now, just because you make the 1/16 ball program doesn't mean that you have to run it. So if a time is a burden, because this tool path is going to take, or it's going to run a lot slower. But anyway, I copied and pasted that program. I'm going to go to my parameters, and I'm going to change the tool to a 1/16 ball. Now, there's one other thing too that you're going to have to change. Under the 1/16 ball, these tools do not come straight shanked. So you do have to worry about your shank rubbing. So if I double click on this 1/16 ball, it's going to bring up the parameters. Now we can see what our tool looks like. You're going to want to change the shank of your tool. So if we change the shank diameter to an 1/8 inch. Okay, now you have these different cutting links on here, so you'll have to go and grab a pair of calipers and measure your own, but they're usually only give you about 200 thousandths of cutting length. And then from there they're going to taper up into, oops, what I do here? Oh, I see. Then they're going to taper up into the actual cutter. So I'll just make this 300,000. We'll make that 200 thousandths. And you can play around with this, getting it exactly how you want it, but just make sure you've got your 1/16 ball and your 1/8 inch shank. Now, by drawing the tool like this, Mastercam will keep it away from areas where this shank would rub. So I'm going to push finish on there. I'm going to slow my feed rate down to 10 inches a minute. And then under my stock, I'm going to give it a roughing tool. I'm just going to tell it that a 0.125 ball, so 0.0625, was the last cutter to go in there. And I'm just going to have it overlap 3 thousandths. And then under my cut parameters, my step over is going to be 3 thousandths. So now this 1/8 inch ball cutter will just go in and cut the areas that this 1/16 ball cutter will cut the areas that the 1/8 inch ball cutter couldn't get into. And it's just going to detail this out a little bit more, make it a little more crisp. So we'll green check that, and then we'll let that calculate. This is going to take a while again. Let's go ahead and take a look at it. Okay, so now that that's calculated, we take a look at the 1/16 ball. It did a pretty good job of picking it out and really detailing out our part. So it looks good. So now I wanted to put one more graphic on here. I'm pretty much done. I programmed get it done beforehand, so I'm just going to go ahead and do it now quick with everybody watching. So go ahead and just follow along real quick. I'm going to use a wireframe, and you'll see. I'm going to use the raster vector to bring in a drawing. And I had a chess folder in here. I believe it's this first one. And this is just kind of a Mandalorian. So I'm just going to take this kind of this Mandalorian picture here. And so get that looking pretty good. Press OK. We're going to just leave that at 200 and green check it. And then it's going to create that Mandalorian drawing. I probably should have put this on a different level before I started, but that's okay. It's right at the bottom of our part. We should be able to rotate and kind of grab a hold of it. So here in a front view and try to grab it. Look at a front view. Yep, I can grab a hold of it level before I started, but that's okay. We'll be able to get it. So I'm going to go ahead and transform dynamic this part. And use that dynamic to move it where I want it to be. Doesn't matter where you grab it at. Over top of the part. Now I'm not worried about getting it exactly on the angle or exactly on the surface, because I'm going to use the project function in Mastercam 9 degrees. all you got to do is get it in the XY position that you want it to be in. And the size you want it to get it positioned where I want it. I'm going to go ahead and do a transform scale and scale it to this size. We're going to project it down onto the surface. So here I'm going to scale it to about 60% of its original size. That looks pretty good. Okay, so I have it now. Size I want it. This really just one more program. What I'm going to do, I'm just going to make a contour program. Is under wireframe, I'm going to project it. Oh, no, I got to project it first. So, yep. So, wireframe project. Select your entities. And do an end select engraving. And then over here, you're going to select on the surface. Select that one blue surface selection, and then it's going to actually move it down to that surface. Okay, and then you can see it actually, now that it's being right on the surface, I can create a contour program. And just now it's exactly incremental depth of 5,000 to do the engraving. And it looks like it could use a little bit of cleaning, some of that but I'm going to, it didn't turn out quite perfect. You can spend a lot more time than what I did, do whatever you want getting this part of it done. Any kind of the very last program on here is just going to be a contour program. So toolpath, contour, and I'm going to use the window function. So to chain this, I'm going to use a window chaining, select all of it, my letters, and then sketch appropriate start point, start points. We go ahead and sketch that, green check. We're going to use our same that 1/16 ball cutter at 5,000 RPM, and we'll just change our feed rate to 10 inches a minute. And then anytime you're doing engraving and want to be right on a line, go to your cut parameters, make sure they're off, turn off, and then the same with lead in, lead outs have to be also off. Also make sure under cut parameters, zero stock allowance. And then under my linking parameters, and then I'm going to adjust my depth, put it at an incremental minus 5 thousandths, minus 0.005. And since that is incremental, you can't see it, it's black right there. We'll just change this top stock to incremental, depth of 5,000 incremental. That means it's going to go 5 thousandths below, and then this is going to calculate really fast, and that's what we want. So then we'll turn our coolant on, green check, and this should be a real quick one. Yep, it's already done. So there it is. Now with everything calculated, we'll go in and just do one quick verify. I'm going to select all, turn everything on, go into my verify, and this may take a minute to load with all of these tool paths. So if it does, just give it time, be patient with it, and then this will also give you your approximate time. Okay, so here we have everything loaded up. You can see our stock toolpaths are still loading. Once they all get there, we're going to go ahead and I'm going to turn the resolution up, all the way speed on all the way fast, and then push play. It looks like we're at about a cycle time of 4 hours. A little off on my time. It's saying 4 hours 55 minutes. I would say the majority of that cycle time is actually spent, not majority, but a big chunk of it is spent with that last 60 ball pencil program. So if you want to post that one separately than the rest of them, then when you go to run it, you can just choose not to run it if you're getting too close to the end of the day and you got to tear the machine down. So it will detail it out and make it look a lot nicer, but it's not necessary. The 1/8" ball does a pretty good detail too. So right now we're looking at the 1/8" ball running, and then here's the 1/16 ball. And being this is a slower feed rate and a lot of tool paths, I would say this is a good couple hour program by itself right here. And it does do a good job of detailing out little figures like the Mando and the Baby Yoda, and even the Razor Crest. It brings out a lot of detail on. And then it shows that engraving there, which I'll turn the wireframe off. You can see there it is. repeat these processes on your